Hey guys, welcome back to lecture series on inverse Z transform. For similar videos, go check in my I button over here, or you can check in my description box. You will get the completely playlist based on the Z transform, inverse Z transform, Fourier sine cosine and their inverse transform, and first unit, okay, which is linear differential equation with a constant coefficient. So if you are interested to see this video, do check in my description. Okay, in my today's video I'm going to explain to you all Z transform for one function, which is very much important. I found plenty of the time such an example in your previous year question paper. Okay, so we're going to solve this example in our today's lecture. Okay, so let me read the example here. We want the Z inverse transform of a Z square upon Z minus 1 by 4 multiplied by Z minus 1 by 5, and that modulus of a Z it is having interval between 1 by 5 to 1 by 4. Okay, yes, so we have less than here, guys. Okay, this one is less than 1 by 5 is less than mod Z less than 1 by 4. Okay, yes, so that we want here Z inverse transform for that sequence. Okay, yes, so we can see that here this one is the sequence f of k. Okay, so what is the f of sequence? F of k means f of Z. Okay, so we consider this one as f of Z. I explained everything in my last lecture. Okay, this is the actual value for f of Z. Z square upon Z minus 1 by 4. Okay, Z minus 1 by 4, Z minus 1 by 5. 1 by 5. Okay, this one is the actual sequence of our given f of Z. Okay, yes, so for that we know that x plus b upon a minus z minus a, z minus b, x minus a, x minus b, that expansion I already explained. Okay, yes, that one we are going to apply here for solving. Okay, so for that what you do, that z it is a power 2. Okay, maybe it will create a trouble for us, so right now take that z to the power denominator of f of Z. Okay, yes, so I'm going to write, okay, that Z as a denominator of f of Z. Okay, so what the next step it look like? F of Z, okay, f of Z upon Z. Okay, I have taken that Z to the denominator here, so I will get the entire value for f of Z upon Z as Z upon 1 Z minus 1 by 4, Z minus 1 by 5. Okay, this one is the bracket complete. Okay, Z minus 1 by 4 and Z minus 1 by 5, it is the bracket complete over here. Okay, yes, so this one is f of Z upon Z. We write Z upon Z minus 1 by 4, Z upon Z minus 1 by 5. Okay, I simplified this one in this form. Okay, yes, now it is a way easier to apply here partial fraction method for finding the inverse Z transform. Okay, so we apply partial fraction method over here. Okay, so let's go for finding the partial fraction method for this one. Okay, so we write f of Z upon Z as a Z minus Z into Z upon Z minus 1 by 4, Z upon Z minus 1 by 4 into Z minus 1 by 5. Okay, this one I written this step over here. Okay, yes, this step I written over here, and I'm going to equate this one with the, now see that some polynomial upon Z minus a, Z minus b it is there, so we write a upon Z minus a, Z minus 1 by 4, some plus b upon Z minus 1 by 5. Okay, this is where I written here. Okay, yes, we go for the cross multiplication then. Z minus 1 by 5 multiplied by a plus, okay, Z minus 1 by 4 multiplied by b. Okay, this into this, total divided by denominator we write Z minus 1 by 4, Z minus 1 by 5. Okay, we multiply this one, so which we could do Z upon Z minus 1 by 4, Z minus 1 by 5. Okay, this is the actual value for this one. Okay, so I written this one in this form. Okay, yes, after applying partial fraction method. Okay, yes, now see that this denominator is similar like this one, so we can cancel this one. Okay, so we can cancel this denominator. We left here with the value of Z which is equal to z minus 1 by 5 into a plus z minus 1 by 4 into b. Okay, so this value I written over here. Okay, yes. Now we want the value for a and b here. Okay, so what we want, the value for a and b. Yes, so now see that for finding the value of a and b, we need to be familiar with the value of z. So that means we want the value for z also. Okay, yes. So how can we consider the value for z? Okay, because whatever the value you are going to consider for z here, you have to replace it here. You have to replace it here. Okay, yes. So if it's possible to make that part 0, that means obviously a goes to 0, you will land on the value for b. Okay, yes. So try to make a 0 here. So when a it is possible 0, when z it is 1 by 5. Okay, yes. So if z which is equal to 1 by 5, if z which is equal to 1 by 5, if I consider, so z which is equal to 1 by 5, so 1 by 5 which is equal to 1 by 5 minus 1 by 5 into a. Okay, obviously see that this one goes to 0, so a completely goes to 0. Okay, plus, so 1 by 5 minus 1 by 4 into b. Okay, see that I have written this way. Yes, now try to solve this part. 4 ones are 4. Okay, so this one goes to 0, so we write 1 by 5 which is equal to 0 into a plus 4 ones are 4 minus 5. 4 minus 5, 5 fours are 20 into a. Okay, so this into this minus this into this divided by this into this. Okay, 4 minus 5, it is a minus 1, minus 1 by 20. Okay, take it to the other side, so we write minus 20 by 5 which is equal to, this goes to 0, which is equal to b. This one is a b here. Okay, this is the b. Okay, so we write a b which is a 5 fours are 20. Okay, so which is a minus 4. I received b as a minus 4 over here. Okay, yes. So if I consider z as 1 by 5, I got the b as minus 4. Now I want that b 0 here. Okay, I want the b 0. So for making b 0 here, consider z as 1 by 4. If 1 by 4, z as 1 by 4, so 1 by 4 minus 1 by 4, b 0. Okay, so if z which is equal to 1 by 4, if I consider z which is equal to 1 by 4 here. Okay, so put this z is equal to 1 by 4 in this entire term. Okay, so we write 1 by 4 which is equal to 1 by 4 minus 1 by 5. Okay, 1 by 4 minus 1 by 5 plus into a plus 1 by 4 minus 1 by 4 into b. Okay, yes. Now see that 1 by 4 minus 1 by 4, it goes to 0. Okay, so 1 by 4 keep as it is. 5 ones are 5 minus 4, 5 minus 4, 5 minus 4. Okay, 5 minus 4 divided by 5 4s are 20. Okay, into a plus 0 times b. Okay, this one is the next value. This one is a plus 4. Okay, yes. So 5 minus 4, it is 1. 1 upon 5 4s are 20. Okay, this one is a 20. 20 take it here. So 20 by 4 which is equal to a. This goes to 0. So a gives us the value 5. Okay, I received the value for a 5, value for b which is the minus 4. Replace a 5 b minus 4 in this equation. Okay, in our z upon z minus 1 by 4. Okay, z upon z minus 1 by 5. Replace over here, so you can replace this value here. Okay, so let me replace the value. Okay, so a upon, that means 5 upon z minus 1 by 4. Okay, plus b minus 5 minus 4 upon z minus 1 by 5. So this one is a 5 upon z minus 1 by 4 plus minus 4 upon z minus 1 by 5. Okay, this one is the actual value upon z minus 1 by 4, z minus 1 by 5. Okay, z upon z minus 1 by 4, z minus 1 by 5. This one is the value for this. Okay, z minus 1 by 4, z minus 1 by 4. But in actual, z upon z minus 1 by 4, z minus 1 by 5, it is the value for f of z upon z. Okay, this is the value for f of z upon z. So I'm going to write this one as a f of z upon z over here. Okay, yes. So we are going to evaluate the value for f of z. Okay, we are going to evaluate the value for f of z. So we want the inverse z transform now. So take that z denominator here. So we have this denominator z, take it to the other side. So it goes to the 5z and minus 4z over here, okay. So take that z to the 5 and 4 over here, okay. Yes. So I'll take it to the next page. So here I written f of z as a, that denominator z I taken here to the numerator, okay. Now this one is the entire, this one f of z, it is the entire simplified form of our given f of z, okay. Given f of z, what we have given f of z, which is z square upon z minus 1 by 4, z minus 1 by 4. It is quite complicated, guys, okay. It is quite complicated. So I converted this one in the form of 5z upon z minus 1 by 4 and minus 4z upon z minus 1 by 5, okay. Yeah, it is way easier. Now we are working on the z inverse transform, okay. So apply z inverse everywhere. So z inverse of f of z, okay. Z inverse of f of z. Now that 5 constant, take it outside because it doesn't matter in our z transform, okay. Yes. So we write the z inverse of z upon z minus 1 by 4. Z upon z minus 1 by 4, okay. Yes. And minus 4 also take it outside, z inverse of z upon z minus 1 by 5, okay. 1 by 5. This one is the way. By using linearity property, I taken this constant outside over here, under bracket z transform of 1 upon z minus 1 by 4, and here z transform of z inverse transform of remaining term here, okay. Yes. So I have to find out z upon z minus a inverse z transform, okay. So already we do have a standard formula for these ones, okay. So we're gonna go for writing these ones, okay. But before that, I have to convert the interval for these two inverse transform, okay. As we have 1 upon 5 strictly less mod z, okay. 1 upon 5 strictly less mod z strictly less 1 by 4, okay. Okay, this one is our given interval for mod z in our example, okay. So using this interval, we are going to divide this value here and here, okay. Yes. So it actually represent two values. 1 by 5 is smaller than mod z, and next value it represent mod z, it is smaller than 1 by 4, okay. Now see that 1 by 5 it is associated with this one, so give this value, it is smaller than to here, okay. Yes. So I'm going to replace, if I'm going to replace 1 by 5 associated with this one here, okay. So that means 1 by 5 smaller than mod z, okay, here for this z inverse, and mod z smaller than 1 by 4 replace here, okay. Yes, because z minus 1 by 4 it is there now, so we want the value mod z smaller than 1 by 4, okay. Yes. So we write mod z smaller than 1 by 4, okay. I replace these two values over here, okay. I replace these two value over here, okay. Mod z bigger than, mod z is smaller than 1 by 4. Guys, we have little correction over here. Actually we want this value positive, okay. So I consider opposite value. We want this value positive, we want this value positive, okay. So for that we need a mod z, okay. Mod z, we want mod z here. See that value for mod z, when it possible, when this positive possible, when z is bigger, okay, and 1 by 4 is smaller, okay. 1 by 4 is smaller, and in actual this value is like this, okay. Mod z is bigger than 1 by 4. We want mod z bigger than 1 by 4, then only this value goes to the positive, okay. Yes. So this this gives us the two different value, but we don't have to take it here, okay. So we consider here mod z bigger than 1 by 4, and for getting this value positive, we want z, okay, that z, okay. See that z is z minus 1 by 5, okay. So for that we getting this one, we want remaining value which possible from here, okay. So if I consider mod z bigger than 1 by 4, okay, mod z bigger than 1 by 4, I'm going to write this one as we want mod z is bigger than 1 by 4. So 1 by 4 bigger than mod z, okay. 1 by 4 bigger than mod z. So obviously mod z it is gives us the smaller than 1 by 5, okay. Okay, so what we have done, I reverse this inequality. Mod z bigger smaller than 1 by 4, and obviously it is goes to the bigger than 1 by 5. In our example it is given, okay. But as we want using this one, okay, as using this one, we taken mod z bigger than 1 by 4, okay. So when it is goes to bigger than 1 by 4, and when it is goes to obviously smaller than 1 by 4, okay. Yes, so we reverse this inequality only, okay. This one goes to this one goes to this, okay. Yes, so what I have done, 1 by 4 I consider smaller, and 1 by 5 I consider bigger here, okay. Yes, so I reverse the inequality in order to maintain the positive sign over here, okay. So if this gives us the two value, 1 by 4 is smaller than mod z, and another value we have mod z is smaller than 1 by 5, okay. Yes, this one. So okay, I'm going to write 1 by 5 smaller than mod z over here, okay. Yes, so this one is way easier, guys, okay. Not that difficult, and mod z is bigger than 1 by 4 it is here, okay. Yes, so need to find out this need to find out z upon z minus a, and mod z smaller than 1 by 4. That means if this goes to positive, we write a raised to k, okay, a raised to k when k greater than 0. Let me write this z inverse transform 5 as it is over here, okay. 5 as it is here, z inverse of z upon z minus a, okay. I already explained z inverse of z upon z minus a, okay, when we have mod z it is bigger, okay, than mod a, okay. Then we write a raised to k only, okay. We write a raised to k, and what is the value for a? 1 by 4. We write 1 by 4 raised to k over here, okay. Yes, minus 4, that minus 4 I taken out here, okay. Z upon z minus a, okay, z upon z minus a, and mod z it is bigger than mod a, okay. Okay, so in this case what we take, okay, in this case we take minus sign, okay. So we take minus sign over here. So what we have here, actually if you want to just experience the value, so you can replace the value over here, okay. Z minus 1 by 5. So I want that z it is bigger than 1 by 5, okay. Okay, z it need to be a, this is the actually we taken one value mod z bigger over here. Now obviously it goes to smaller, guys. This is we made little mistake here. If mod z is bigger than 1 by 4, then another value obviously smaller than 1 by 5, okay. So mod z smaller than 1 by 5 it is here, okay. Yes, now we can see that this one is the right interval, okay. We replace another value, that's why it is quite confusing for us. This one is way easier to solve, this one here, okay. But now remember, one interval I taken this one, another it is here, okay. So mod z is smaller than 1 by 5, and mod z smaller than mod a, we write minus a raised to k minus 1, okay. We write minus a raised to k, okay. So minus 4 under bracket minus 1 by minus a means minus 1 by 5. What is the value for a? It is 1 by 5. Minus 1 by 5 raised to k, okay. This one is the value, and k it is obviously goes to smaller here, okay, and k obviously goes to bigger here, okay. Yes, this one is our required z transform, guys. Not a difficult, okay. It is way easier. Just need to understand the condition. We got the little confused about this condition now, that's why we made here some little confusion, but it is not the difficult, guys. It is way easier. I tried my best to explain over here, but even after, if you found anything difficult now, guys, let me know in my comment section. I will come up with a similar videos, guys, okay. I hope you all have understood my entire today's session. So even after, if you found anything difficult, guys, let me know in my comment section, okay. So that's it for my today's lecture. We're gonna see a next point in our next lecture. So thank you everyone, thank you for my today's lecture.